So we've been speaking about grounded theory, thematic analysis, coding several times. So now we see what is this about. Up to now we've seen data collection strategies, and now we focus on data analysis activities. So in particular on one strategy that is called grounded theory. So this is a scheme that you should read from left to right, and that describes the first steps of grounded theory. As the name says, and as we know, every time we do some empirical research, qualitative, quantitative, we are targeting theories. In this case, we want the theory to emerge from the data. So we start from the left with the sources of data, which are here depicted as people. Of course, from these people, I can I can collect qualitative data such as observation, interviews, or documents, as we saw before. Then I perform what is called coding, which means assign labels and tags to relevant text in these interviews and observation. In this content, I may find, for example, if I am focusing on relationship in a company, I can find that some sentences are speaking, some of my developers are speaking about the fact that they are very happy with their boss, but they are unhappy with colleagues. And I can identify these common topics in several interviews. So I label them. So I add codes to them, and this activity is called coding. After this activity, I can understand also that these people are speaking about certain causes for happiness and unhappiness in their working place, in their working environment, and so I can create a sort of structure of the themes that have emerged throughout the interviews. So coding is and relating codes and themes one to the others is called thematic analysis, which means identify patterns and abstractions in code. So looking at these items and the coding that have been done, that you have done on the based on your interviews and documents, you try to abstract, you try to find relationships, find patterns, and identify, for example, in this case, causes of unhappiness and causes of happiness, and relation about them, for example, relation about the possible causes. Then there is a fundamental element of grounded theory that is so-called constant comparison, which means you compare the abstractions that you've made, so the scheme of interpretation that you made through thematic analysis, with the data that you had. So you again go back to the data and see whether those patterns actually always work in the data. Finally, after you have done this, you may have reached a point in which you understand that your theory, the information that you have is not enough, for example, because you need to interview additional people, you need to involve additional people or additional document, and this leads you to further sampling your population of interest, and this is called theoretical sampling, which is searching for additional data sources based on the theory that you've developed. The theory that you've developed up to now is the output of this thematic analysis that explains the causes of unhappiness and the causes of happiness. So you understand, for example, that there are many more reasons for unhappiness and few reasons for happiness. So you want to understand whether this balance, this imbalance, is due to a reality or is due simply to the way that the interviews were framed, or the way you observe the people, or the attitude of the people. So you interview additional people, for example, focusing just on aspects related to unhappiness. And this cycle is repeated many times until you reach what is called theoretical saturation. So you have covered, let's say, all the themes that that appear relevant to you. All the aspects and topics that that have emerged from your theory are backed by the data, are grounded on data, and you've found data supporting them. You have coded your data in a way that is clearly connected with the text, with the information that you've gathered, and you have defined your thematic analysis with a clear connection with the codes that you found. You find yourself in a point in which there is no more need to collect qualitative data, to code them, or to better define your theory, your thematic analysis. And so you reach the so-called theoretical saturation. Theoretical saturation, as we will see, is just a feeling. Okay, you feel that you've covered what you wanted to cover, and you know enough. This is a very weird thing to hear for engineers, but that's the way it works. And there will be a point in which you understand that you have a sufficiently complete view of the problem that you're analyzing. So let's see more in depth this overview, how to do. After this overview, let's see how to do the different type of activities, and let's see some definition here. Some definitions. So grounded theory is a systematic technique to support induction of a theory from qualitative data. A remark that we are using an inductive process. So we start from the data and we want to build a theory. In the literature, as I said also in the previous lecture, grounded theory and thematic analysis are treated as separate techniques, but this is due mostly for historical reasons. There are different schools of grounded theory, and thematic analysis is a strategy that is not, it doesn't have a very clear structure like grounded theory has. For our purposes, for this presentation, and also in general for most of the software engineering goal, because grounded theory comes from social sciences, and they have different goals that do not always match with ours. In grounded theory, in our lecture, we will assume that grounded theory is a framework that includes thematic analysis, which makes use of coding, which is labeling chunks of qualitative data. We will see example. The grounded theory process starts with the initial data, as I described, which can be any type of qualitative data. The researcher critically reads the data after having collected them and add labels and memos with how does he do this. There are tools. One is NVivo, is a commercial tool NVivo for doing these activities of coding, and but often you just resort to Excel. So you take excerpts of your data, you place them in Excel, and in one of the columns you write your codes. Then is based after this code, after the identification of these codes, of these concepts, actually, we'll see we create higher level categories, and afterwards you search for patterns within the data, so recurrent themes, relation among themes, etc. So this is the approach that is normally used. At this stage, I'm using themes, code, concepts, categories somewhat in an ambiguous way, because this is the way you often find also in the literature. Don't worry, I will clarify the different terms very soon. Now I have used them interchangeably and in a liberal way. Grounded theory process requires constant comparison with the data, as I said, to check that the theory is in line with the data. So I want to always check that what I have extracted in terms of themes is actually meshed in the data that I've collected and in the codes. Thematic sampling, so sampling of new subjects and new information in general based on the current theory to get additional data to validate also the theory and to verify that certain patterns that I suspect in the existing data are actually general patterns that manifest themselves in a wider population. And it's based on theoretical saturation. So as I said, you stop when you feel nothing new can be discovered. So you stop your data collection activity, because this grounded theory is not just for the analysis, but with thematic sampling, it involves also the data collection activity, because it drives you towards the collection of additional data. Of course, the core part is the analysis part. Basically, all these words to tell you that grounded theory is glorified abstraction from data. Basically, you take the data, and in a structured way that is not, in the end, it cannot be communicated clearly unless you do it and you try it out. Basically, you do the most human of the things, that is abstracting information from your data and creating, in a systematic way at least, some general theory by looking at qualitative information. Coding, we've seen from the picture, that is one of the building blocks. Coding is one of the building block of the grounded theory, is one of the building block of thematic analysis. A code is a qualitative inquiry. A code in a qualitative inquiry is a word or short phrase that symbolically assigns a summative, salience, essence capturing of evocative attribute to a portion of data. Is basically a label that means something, that means that associates some also reflection to your data. We will see examples. There are two distinctions in the technique, in the approaches to coding. One is open coding and the other is closed coding. In general, grounded theory focused on open coding. That means that codes are not predefined, so these labels that you assign to text are not predefined, but are invented by the researcher while the researcher reads the data. In closed coding, codes are predefined, and they may be based on existing literature or on some consolidated codes that are derived from a previous activity of open coding. So you first analyze your data, identify a set of codes, and then use these codes to code new data. And this is similar to classification, so similar to labeling and classify sentences based on what you found before. For example, if I'm doing an interview about typical defects, I'm doing research and a series of interviews on which are the defects in requirements. Basically, at the first stage of open coding, I might find a list of typical defects and that are mentioned, and in the second phase, I may be able to use this type of defects to code new interviews to understand whether other defects emerge, for example, and to find if the code that have been identified on the previous data are appropriate to analyze also the new data. But for grounded theory, normally rely on open coding. Is an iterative activity in which you chain names and you link code to each other. And as I said, it's not just labeling text, but it's creating the abstraction, understanding what's written in the text. Here is the different coding phases, because coding is in grounded theory is distinguished between open coding, axial coding, which is thematic analysis for us. This is not written in any book, but for us, axial coding is equivalent to thematic analysis. And selective coding, which means theory generation. This is quite confusing, because selective coding is basically a way of re-elaborating your codes to produce a theory. Is not just is not coding the data. So in open coding, you label your data. In axial coding, you relate your data in some way. You relate your codes, your labels. And in selective coding, you do a selection, you identify the main category, and you derive the theory. These steps are done through a constant comparison with the data. So the key here is that in open coding, you start and you identify the so-called concepts. So they are more low-level codes. Then you group these concepts into categories, but you have to check that the data actually respond to what you found. Then you pass to the second step, which is axial coding, which we call also thematic analysis, that consists in hierarchically categorizing the different categories and the relations with the codes. Okay, so you have concepts, categories, and a hierarchical structure, and probably find the relationship that may occur, not just hierarchical, but for example, cause-effect relationship between the categories. And finally, you pass to selective coding, which is theory generation. Throughout this process, as said, you need to check that the relationship actually apply on the data, so they are evident, these patterns that you found on the data, through constant comparison. And the same thing for theory generation. Of course, you have to test the theory with the data and also perform possibly theoretical sampling if you need additional data and you didn't reach the so-called theoretical saturation. In all this process, a thing that you always do while you are coding this data, analyzing, is applying the memos or analytic memos. These are just annotations that are associated to reflections that you make while you read these interviews and code them. This is just a process that is very similar to studying, so it's not it shouldn't be unfamiliar to you if you try it out on real world interviews, because it's studying the content, annotating and writing down thoughts that can be useful for you to pass, for example, from the coding stage of just labeling to the axial coding stage that is concerned with relating codes to each other, creating hierarchical relationship or other type of relationship. In these memos, you just write down what you think. So this is useful to better express the concept, similarly to the diaries in observation research. But in this case, you are not taking notes on what you observe, but you are taking notes on what you are reading that may come from the interview or from an observation. Open coding. So this was an intermission because it is pervasive, taking these memos, this concept of memos that again is one of the seems an obvious concept, but is still but is central in this activity, and it occurs in any stage. So for open coding, thematic analysis, and the theory generation phase. Open coding is described here and is oriented to identify initial concepts and group concepts into categories. So here our definition comes. So concepts and categories. Concepts are lower level and categories are higher level. There are different types of coding. There can be descriptive coding that are associated to the topic of the data. For example, someone may say, I lose sense of time when programming. A possible code in this sense is sense of time. This guy is speaking about sense of time. There can be also a type of analytic coding. So that is higher level from an abstraction standpoint and derived from the researcher reflections on the code. For example, I lose a sense of time when programming can be coded in an analytic way with the term engagement, because here I can assume that the person loses temp of time when programming because he's really engaged in the activity. It can be positively or negatively engaged, but the person is engaged. You understand that is more abstract than the simple sense of time. Or process coding, I focus on the action that are performed. Instead of the sense of time, if I work on actions, I'm focusing on programming. Possible code is programming. It depends on what is that appears more relevant to you in relation also to the other data. But you can associate multiple codes, of course, to the same chunk of same chunk of text. And especially in the initial phase, it is important that you use a different type of code for the same chunk of text. The techniques to start this coding activity, this labeling activity, that means taking your, imagine, now you don't know NVivo, but imagine using Excel. You take these documents in which it's written, the interviews are transcribed, you select the relevant part, you put them in an Excel file, and you write down in another column a set of codes, a set of labels. Okay, a set of tags, basically. This is what they are. The techniques can be in vivo coding. That is a good technique to start because you select the keywords directly from the data. Line by line coding, which is also a good technique to start because you just consider the line, or you just consider the single line of text. So without considering whether there is a period or is a comma or whatever. And you just code line by line, and you find yourself with several codes. This can be useful to make sense of the data at the beginning. Or sentence coding, which is the thing that is more likely for you to perform. So you highlight the sentences that are really relevant and assign a code only to them. This is a good balance between being quick and do an in-depth work. So the suggestion here is do sentence coding. Start with descriptive and process coding, so focus on the topic and the actions, and then pass to the analytic level. So if in your Excel file, start with the descriptive and then reason on possible analytic coding. What should I look at? This is just a list of things that you should look at. You should look at specific units of social organization, and by looking at it from a certain perspective, you can realize different analytic code. Different analytic code here is mostly related to the type of analytic code because we are putting some perspective, some analytic perspective on it. The units may be practices, roles, artifact, tools, groups and cliques, so teams, organizations, spaces, episodes, encounters. So this is just a list of with associated example that you can look at yourself of the unit that may be relevant to you. But the thing that is important is that at the same unit, you can look with different perspective. For example, you can use a factual perspective in which units are as they are written, so it's more just descriptive in some way. Cognitive, so units that they are interpreted by the participants of your study. Emotional units that they are perceived. For example, a certain activity may be perceived as boring or stressing or really engaging. Learning units that they are learned. For example, the way that certain software, certain new tool is learned by the people, or on the organization level, the way that novices understand the way that the organization is structured. Or again, in relation to episode or encounters, you understand that you can both have an emotional perspective or a learning perspective, or finally a relational perspective. So units as they are related to each other. So relation between artifacts and tools, relationship between people and or roles and a certain practice. So units look through a perspective, generate a possible concept, which is a basic code. Okay, a possible concept from an analytic point of view. Okay, so analytic, let's remember, are more related to the reflections. Okay. Okay, open coding, passing from concepts to categories. Again, let's start from the sentence before. I start from that sentence and I see that I lose sense of time while programming. Here, I have labeled it with sense of time, engagement, and programming. Then throughout the other interview, I see that someone is saying, when I get stuck with a bug and cannot solve it during the day, I often wake up at the night with some idea. This is related to the activities of sleeping, is probably tormented by the bug, and the activity that he's doing is debugging. So this is different, because before I was speaking about programming and losing sense of time in some probably positive way, although we don't know, and it is tormented while sleeping. Another person may say, or the same person may say, when I have to solve a bug, I forget to eat. Here is related to debugging, is related still to engagement, probably negative engagement in this case, and to another activity that is eating. And finally, when the program seems to work and it is late afternoon, I force myself to stop and go out. So because it is successful, so it's basically better to stop and going out. This is related to programming and the activity, to two activities, that is programming and going out. So a certain reaction in this case. I could have labeled also reaction, for example. These are all my labels or my codes, and are my concepts. Concepts that are at different levels. You see activities or feeling. In this case, for example, engagement is more related to an emotional perspective on a certain activity that is programming. So you see that I can partition my concepts already into two main categories: the activity categories and the feeling category, because these are the groups of elements that I find in my code. This is really, now it seems easy. It's not always easy, because I understand afterwards that these people are speaking about activity and feelings. I didn't know in advance, so I may have introduced a lot of codes that do not fit with this vision, and a different vision may be included. So you already understand that the researcher here is playing a fundamental role in creating this theory, because at this level we are already creating the theory. We start from the concept and create the category, group into categories. Then we do the axial coding, so the second step, which is thematic analysis. Basically, which is again equivalent to thematic analysis for us. Axial coding is oriented to identify a graph of categories and concepts. Axial coding, in our case, again, is remarked that is thematic analysis. Of course, we can have different types of links between categories and concepts. So category higher level, concepts lower level. They can be linked by similarity, they can be linked by hierarchy, so similar concept, or opposite concepts like engagement and torment, for example. By hierarchy and by causal relationship, so one thing that causes another. If needed, throughout the process of constructing this link, you can add also new codes and new subcategories or new categories, and always do this constant comparison. Always compare your graph, the graph with your data. This is a fundamental activity to do. Do not get lost on things that you think, but that you think should be in the data when they aren't there. So you must be honest with your data, and if you search for something specific, do thematic sampling. Here is an example. So I had activity and feeling, and I saw that I want to create some relationship. By creating some relationship, I create also some subcategories. So a hierarchical relation. The new categories are work and life, because the activity can be separated between working activity, for example, programming and debugging, and life-related activities. So sleeping, go out, eating, in the same example. You understand where we are going. And I can see that the activity has some relation with the feeling. There is a causal relation with the feeling, because some activity leads to engagement. Some activity leads to torment. So again, when you found we have built this graph, you have you have to search for these categories and relationship and patterns in the text, and you may find additional concepts, categories, and relationships. So this construction is incremental. You remember the constant comparison between the theory and the data. For example, I search other data and I find that during the meetings I feel the urge to say my viewpoint, but in the end I don't. So here we have another activity related to work that is meeting. And I may want to understand what feeling does it lead to. Okay, because here is not clear. So I may want to ask further questions about this topic. So this leads to further theoretical sampling if I don't find information in the data. Leaving things as they are make me frustrated. Again, there is another type of feeling that is frustration, and may be connected with some specific activity. When does this leaving things as they are happen? During programming, during debugging, during all the work activities. So you understand that it is not simple, because you are dealing at the same time with codes, with your current theory, with information that you have up to now, so the interviews, and information that you might need to search further. Finally, you have selective coding. That is also called theoretical coding. It is a theory generation. Basically, these are the names that I used. This consists in finding the message that groups all the other categories, and this can be a single word or a concept that categorize all the data, and is basically the title of your article. For example, in relation to what we saw before in our very small example, our article can be titled "The Cycle of Developers' Emotion." Okay, this is a set of minimal concepts that allows us to understand the essence of our theory, that is concerned with the emotions and the activities associated to emotions, and to a mutual cycle that occur between activities and emotion in the developers. And the hypothesis associated to this single word or concept or minimal set of concepts is expressed in a sentence, just in a sentence. Developers' working activities have an emotional impact that has consequences on daily life activities, because this is what it is. You know, the person forgets to eat, the person cannot sleep if they have to debug. So activities related to work have an impact on daily life activities. This may look as an obvious reflection, but it just emerged when you saw it from the data, and is one of the most relevant things that probably emerged throughout those interviews. So this fact that is grounded of the data gives power to something that may be even common sense. Of course, if you discover aspects in the reality that are less common sense than this one, even better. But also finding something that is common sense, but grounding that on the data, is extremely important. Then I collect other data and verify that the data are in agreement with my hypothesis. So I do what we call theoretical sampling. And at this point, my hypothesis becomes a substantive theory, or gets adjusted based on additional evidence found in the data. So if I am verified my theory, I've validated against new data, I have reached saturation for this phase, and I can consider this stage as a substantive theory. Then I can apply my theory to other settings. For example, instead of considering developers, I consider managers. And if I see that it applies, so if my data, so the interviews that I make, leads to an agreement with my theory, it becomes a formal theory. Formal theory is some higher level stage, okay, with respect to a substantive theory. very often in software engineering, theory stops earlier than this searching for additional evidence, because so you are just proposing a theory that is exploratory many times, because is an early theory building is not so developed, and also because for practical reason in a company very often you have a set of interviews that you can perform in a certain time, and sometimes you are not allowed to go back and continue for more than 1 year in interacting with in gathering information. So there are limits also from the logistic point of view. So this is the overall process. So as grounded theory should be. So you start from research question, you do theoretical sampling. Theoretical sampling can be done also at the beginning. So you select the people based on a preliminary research goal. Okay. Then you collect your data, you do open coding, produce concepts, you do constant comparison and create categories, you saturate your categories, so you are sure that in this activities you have exhausted the type of categories that you have analyzed all the data that you have. Then you explore category relations and hierarchy and produce your hypothesis. So that is your structure, your set of themes, because this is the activity of thematic analysis, basically. And you do theoretical sampling, so collect new data, and you reach to a saturation of categories and relationships. So after interviewing other people, finally, you test the hypothesis. This is what I was saying in the previous slide. In this case, you are generating a substantive theory. So you compare your hypothesis with the new data that you have acquired, and also with respect to the existing data. And then you can pass to another setting and collect and analyze data. And if your theory gets established and you can show that is grounded also on those data, it becomes a formal theory. The main issue in grounded theory is understanding whether are finished or not. So there are of course techniques that are mostly qualitative to understand whether you have reached your saturation with respect to your code, what you can find in the data, and what you can gather from the data sources, so people or documents. There are some practical techniques that can be used to elicit a theory that does not want to emerge, and that let you understand whether you reached the theoretical saturation or you need to find additional data. First one is top 10 list. So you take your data, you select the most relevant quotes for you, like at first glance, 10 relevant quotes, and then you combine them chronologically, hierarchically, episodically, narratively, and you may order them from expository to the climatic, from the mundane to insightful. So in different ways, combine them in different ways, and try to see whether from this combination of quotes you can derive a possible hypothesis, initial hypothesis that you can test. Trinity test. Take the most relevant 3 categories, find the dominant one or relationship among them. This is also a strategy that you can pick. So you find the most relevant 3 categories and you want to understand the focus of your theory. The touch test. This is very important for understanding whether your theory is abstract enough. The idea is simply that if you can touch it, it is not abstract enough. For example, you can touch a programmer, but you cannot touch software development. So if your theory is speaking about software development, okay, you are closer to the level of abstraction that may entail a theory, may lead to a theory. If you can touch all the elements, all the categories of your theory, then you are not building a theory. Okay, you are still in the early stage. You are not abstract enough. Or code weaving. So take your codes, categories and concepts, and combine them in full sentences, and pick the sentences that make more sense to you. So this is almost a random way of try to get info from your data. Okay, these are just tips for reaching some theory from a large amount of data. Other tips, the code book. Whenever you code, the suggestion is to have a code book, at least after a while, when your codes become more consolidated. And each code should be detailed. This, of course, takes a lot of time. You need the name of the code. This is a short description, a detailed description, something that gives meanings to that code, so the label, to your label. Some inclusion criteria, so criteria that you should use when considering whether a sentence or a fragment can be associated to that code. Some exclusion criteria, the opposite, and some typical example, and some special atypical examples, so cases that may lead you to think that they represent the code, but actually they don't. This is made mostly for you, because you will find yourself, because this is a process of classification, and at the same time inventing the classes, and exploring whether your data match with your the classes that you have in mind. And this is not easy, so you need to be structured in this way, with typical examples, atypical examples, and close but no. So that example that could mistakenly be assigned to this particular code. So the opposite that of a typical example, basically. So atypical exemplars. So cases, the atypical exemplars are those cases that may not seem to belong to that code, but they actually represent the code. And close but no are data that can be mistaken for being related to the specific code. Of course, this is just, if you want to do the things in a very precise way, here there is a reference for a book on coding that is quite verbose, and but there is a large literature on that. If you want to be precise, this is the strategy to follow. The suggestion is do this when you've reached a more limited number of codes, so you've discarded those that appear irrelevant to you. Qualities of the coder. Of course, you understand that you need to be organized, because this is a complex process with large amount of data, Excel files, en vivo. You need to be extremely organized. You need to be perseverant, because it takes a lot of time and you may feel lost, especially if you are organized and control freaks. So if you're very organized, the data, of course, they are not in themselves organized, and they always show something that you didn't consider in your theory. You have to deal with that, and you have to deal with ambiguity, as it's written there. You have to accept that reality is shaded. What you find there will not match fully what your theory says and what you have in mind. So you have to be flexible, because you may need to reorganize your codes and change your theory, because the data that you collect may say you the opposite thing with respect to what you found up to that moment. You need to be creative and have a strong ability of abstraction. This is really important, because, as I said, your theory may also say something that is trivial or obvious, but is more relevant for research, from a research standpoint, that the theory says something that is not straightforward, that is not too straightforward. Even the theory that exemplifies, so the impact between the activity of daily work and the activity of daily life and their relationship, is something that may look trivial, but actually is not. It's not something so obvious. It's not something that you reflect on every time. The fact that you bring out from the data and from this process of abstraction leads to something that was obviously there, but its relevance was not considered enough. And finally, honesty with the people and with the data. So don't invent things that are not there, and be honest with what the people say. So adhere to their word, adhere to their expression, and also test with them what you found. And we will see this in the threats to validity in qualitative research. These threats to validity are valid for both interviews and observations. And they are oriented, like any threats to validity activity, to ensure the quality of my qualitative research. There are several criteria to assess validative or qualitative research, but there are two main fundamental techniques. One is the so-called responder validation or member checking, which means check with the people that you interviewed or observed that they agree with your findings, that your interpretation of the reality of the observational interview actually match with their viewpoint. This is really important, because otherwise your interpretation may be completely different. Like in the example that I gave you, when I was observing the person, the customer and the interviewee, and I thought that the interviewee was extremely professional, while the customer thought that he was extremely annoying and too much self-confidence. So we had a completely different point of view. So every time you want to express some opinion, check that the person, your interpretation on some data, check that the person that is involved in your observation agree with the finding that you derive and agree with your theory. In some cases, you may have some defensive reactions and some censorship, or they may agree even out of respect for you, or they may not understand. So it is, of course, tricky like any human activity. Finally, triangulation. So triangulation means look at different data, interviews, for example, and observation, and, for example, archival data analysis. So combine all these things and involve other subjects to cross-check your analysis. The best is to be, for example, to ask the supervisor, your supervisor or another colleague to do the data analysis in parallel, for example, to do at least the coding activities in parallel, so that you can do the axial coding together, so the phase in which you relate the codes later on, but you have identified the codes in an early stage with two different viewpoints. This is a strategy that you can use for ensuring better quality. You cannot do much more. You cannot do much more in qualitative research. These are the things that you can do to mitigate some threats to validity. Threats to validity that are summarized in two main qualitative criteria. One is trustworthiness, and the second one is authenticity. Trustworthiness is related to these four quality aspects. One is credibility, which is, did I really understand the context? Of course, mitigation is mitigation. The strategy that I adopt to increase my credibility is the triangulation and responder validation. Transferability. To which extent the findings can be extended to other contexts. And this is very difficult because you normally focus on a single group, a single company. The issue here is you have to provide a very thick characterization of the features of the context. We will see better this when we will study case studies, because case studies are typically for context dependent, but another person that reads your study, if the person understands the context of your study, can probably understand the features that can be transferred to their context, and understand also to which extent the conclusion of the specific study can be ported to another context. Dependability. Can my research be assessed? So how evident is that those codes actually emerge from the data and the theory emerge from the data? This you do it just with an external peer audit, so another person that checks what you have done. Is it evident that I actually acted with a bias? Again, another point of view is needed, and this is related to so-called confirmability. Authenticity, second criterion. Fairness, so did I represent different viewpoints among the different members? Ontological authenticity. This is on authenticity are mostly related to the relationship between the research and the actual output of the research and the participants. Okay, so ontological authenticity is related to the extent to which you have helped members to arrive to a better understanding of their context. So when you do member checking, do you find that they are surprised with the findings that you bring in? Educative authenticity, did they learn? Did these people show to have learned something about their context? Catalytic authenticity, as the researcher acted as an impetus to member to engage in an action to change the circumstances. So after they've understood that there was some problem, for example, in the relationship that they have between developers and testers, do they have do they feel the need to change this relationship? And then tactical authenticity. That means, did these people actually, are these people actually performing actions to improve their relationship? And this is a very long list that for evaluating your qualitative research. Okay, and this basically is focused, is a checklist for understanding to which extent those criteria are fulfilled. I don't go through the whole list. You can find it in the book, and it is useful when you write your own report and you want to judge it, of course. But you see that it is a way of rephrasing what you've already seen. What you write in a paper. In the paper, you write the same section that is called threats to validity. And in qualitative studies, you have three main types of threats to validity. One is reliability, which means how consistent and verifiable are the findings? Is it clear the link between the data and the theory? So this is reliability, and you have to show that there is a relationship between your data and your theory. How do you do that? In interviews is not quite easy, but it's easier than for observations. Okay, I will give you example later on. But the thing is that you need to share some data, and you need to share the codes, the definition of the codes in the codebook that is useful for reporting, the tip that I gave you. And you have to give a thick account of your process. This ensures the reliability of the data. Validity is related to how appropriate is the research design. Have you spent enough time in the company? Have you interviewed the right roles and the right people? How did you guarantee that? Have you performed triangulation and member checking? So this is mostly related to the so-called internal validity, okay, of your research. And generalizability is like external validity, because it means to which extent the findings can be applicable to other settings. And in this case, you characterize your salient characteristics of your specific context. So, for example, nationality, number of employees, domain, and infer which context may be similar. For example, I've performed a theory in a company that is railway safety critical sector. I can assume that company in other safety critical sectors, such as steel in transportation, for example, automotive sector, can be similar enough, and the theory can be applied also for this context. In this is as we saw. For quantitative study, is the relationship between the different phases and the threats to validity. So internal validity is mostly related with the research design and the data collection. Reliability is related to the way you analyze the data, because reliability is related to how much traceable are the codes and the theory that you are bringing. And generalizability is related to the recruitment of the subject. So to which extent have you performed an effective thematic coding, thematic sampling? This is an example. To give you an example, take it from a paper. The goal is to study the impact of requirement practices on development speed. So how much doing requirements affect the speed of delivering software? Of course, the natural thing is I write more requirements, the software process is lower, but I can increase the quality, for example. So these people went to two automotive companies and asked, and their research was focused on these three research questions. So which aspects impact development speed, which new aspects should be considered when defining a new way of working with requirements to increase development speed, because they understood that they were slow in deriving software and they wanted to pass to a process that was more agile, quicker. To what extent will other aspects be addressed to the ongoing agile transformation? Because this was an idea of these companies. They were automotive companies wanting to introduce agile principles, so principle of fast prototyping and based on more modern techniques than the so-called V-cycle that is another process that is slower, another type of process that is focused on requirements, strongly focused on requirements. And they performed 30 interviews with managers and technical experts from a company. This is the research, and this is the theory. This is what they actually produced. It is a group of categories, okay, and relationship between categories. The core category here is development speed. They understood that there are some categories that have an impact on that, and these categories are separated between current practices and possible future practices, and the relationship may be positive or negative. For example, the requirement style, RE is requirements engineering. Requirements engineering style dominated by safety and legal concern in the corner there. Is not in balance, so it affects negatively the development speed. I have to, and this is something that emerged from my data. How can I show that? I show that by writing in the paper my code, my category in this case, and I write down some introduction, and then I report the quotes from the respondents that allows me to show that that were associated to the code, basically, that allow me to show that my data are actually clearly linked with the category. So here we have a person, for example, third respondent, third person interviewed, that is speaking and saying, we have product liability, legal requirements, documentation obligations. This is focusing on the legal aspect and safety aspect of their current process. Okay. Summary. So summary to wrap up this long module on qualitative studies. Qualitative studies in software engineering are useful to identify human-related and social aspects and opinions, like in the study that we saw as an example, very quick example now. They are useful when your research is at the exploratory stage. Very useful because you don't know much of a certain context and you want to have a complete overall view, not too detailed. Okay. They can be used at different research strategies. We've seen in different research strategies, for example, field studies, but also you can imagine to do this coding also for surveys, or these coding activities also for literature reviews, or but in general for field studies and field experiment, they are the most common cases. Data analysis is based on coding, labeling, thematic analysis, relating the themes and building the graph, and grounded theory. Grounded theory means identify the theory that emerge and summarize in a simple sentence the whole graph. And are often performed in the context of case studies, so field studies and field experiments, as I said before.